Hello, Martin Warwick here at the Small Cells World Summit 2014 in London's Docklands, and I'm talking with Nick Johnson, the CTO and founder of IP Access. Nick, how does small cells for 4G and beyond fit in with the move towards NFV, Network Functions Virtualization?
Small cells, the motivation for small cells, as I'm sure you know, is about increasing network capacity. So there's only a limited amount of spectrum there available. There's a limited amount you can do on the radio interface itself in terms of getting the signal out into the air. And the rest you have to do by shrinking the cell. And one of the ways to do that, well, there are some techniques, but the favourite one, and the one we've been doing for the last 15 years, is small cells. Starting in GSM 2003, when we were first product launches, and then 3G from 2008. And then most recently LTE for the last year or so. But the small cell being a cell which is of radio power of a few tens or hundreds of milliwatts, of a range of a few tens or hundreds of meters, comparison to a macro cell which is maybe many kilometers of range. So it means you can serve the whole of the air interface, the whole multi tens or hundreds of megabits per second. You can serve a smaller number of users. So that's really the rationale. You're dividing those air interface radio resources amongst a smaller number of people so that each person gets a bigger bite of the cherry, as it were. So they get much better, more satisfying experience in their smartphone or iPad or whatever. And the network function virtualization thing is really a continuation of a trend that started in the data center, where compute resources within a data center were being unused. So computers were running software which was dedicated to the hardware, and the actual resource utilization was very inefficient. And so people were having to install more and more hardware to carry less and less traffic. People figured out that actually if they virtualized the environment in which the software ran, you could collapse the hardware down onto a smaller number of servers and run with a much higher efficiency, a higher occupancy of that hardware, and serve more users with the same hardware. So the same logic is being applied to the RAN, to the radio access network, and it's a bit more complex because traditionally radios are they're not general purpose computers, so they have some special purpose hardware, some application specific hardware that traditionally has been very hard to virtualize. So that's our challenge really, is to understand how to virtualize those things which look very specific to a particular user, a particular process, a particular bearer, particular application. Those things are a bit more challenging to do. In the data center world, the server world, the key thing is the context. So for a particular transaction, so when you're browsing to a web page, there's a very simple transaction which is a get and then the response, and then that get and response is handled by a virtualized server, and the virtualization layer within the data center then decides which hardware is actually going to serve that request and delivers the content accordingly. In the telecoms world, those transactions are more like sessions, and they're longer, and they need more continuity between them. So one of the challenges going forward is to understand how we relate that session context continuity to a virtualization where actually the ideal is that any part of that transaction can be handled by any part of the hardware. But it doesn't make sense if you're continually forgetting where you are in the process and having to restart it. So maintaining that session continuity across within a virtualized environment is the challenge. But it's one that's actually beginning to start, and I think the gains from it are one of the things that we're trying to understand at the moment. Why would we do this? The actual real hardware is pretty cheap already, and pretty well understood. And the challenge again in telco is that you're virtualizing something which is quite widely distributed. So the radio heads are all over the country, all over the street. They're not concentrated in a data center. So how can you achieve those trunking gains over hardware which is quite widely dispersed? There's a parallel move to centralize a lot of those hardware resources, which means putting in quite high performance networks between the data center and the radio head, And so what's the relative cost of all that? So it's quite a challenging problem, but the benefits are potentially pretty high.
What's the business case for carrier Wi-Fi? Lots of people say there isn't one.
Well, I think there is. And the reason for this actually is related to another trend in the industry, which is about licensed, unlicensed convergence. And the key, I think people have been talking for many years about Wi-Fi convergence. How do we converge Wi-Fi that we all know and love and use every day with licensed radio? And that's been a bit of a challenge, but there's a new player on the block, as it were, which is so-called unlicensed LTE, and that really changes the game, I think, in terms of that convergence play. And I think the way in which operators access that unlicensed spectrum using Wi-Fi, using LTE or Wi-Fi, is now the important question. And the business case for that is much clearer, because it's all again to do with the increase in network capacity. So people have been projecting 1,000-fold increases in data demand over the next few years. For over the next couple of years, if you look at the forecasts, they're actually starting to slow down a little bit, but certainly over the next 2 or 3 years, it's still doubling year on year. It's going to slow down, I think, towards the end of the decade. But even so, it's very quickly going to become, the grains of rice on a chessboard problem. You're very quickly going to exhaust all of the spectrum you have available. And one of the ways to fix that is to give yourself much more spectrum, which is to leverage the huge amounts of unlicensed spectrum that there is available at 5 gigahertz and at 3.5 gigahertz, and converging that using LTE-U and using Wi-Fi. So 11N uses 5 gig spectrum already, is the key to that success. And so the business case is about giving yourself a higher performance network without having to redeploy whole huge swathes of new technology, new cell sites and so on. You're just giving yourself access to more spectrum. There's a common myth, I think, about Wi-Fi, which is that it's free. There's always a subscription to Wi-Fi, whether it's your own home or in the enterprise or in a public Wi-Fi setting like this. There's always a subscription. It's just that it may be hidden from you. The carrier Wi-Fi proposition is about recognizing that and saying, well, actually, let's use the Wi-Fi or the unlicensed spectrum we have and couple it together with your existing licensed radio subscription and getting the benefit from that. So that you're giving, the business case is about increasing the performance of your network in a very cost-effective way and handing on those performance gains to your customers.
How can Wi-Fi be used, do you think, to drive new revenue channels?
Well, I think this is a new revenue is always a challenge, and I think one of my themes this week, I gave a presentation yesterday about presence, and to be honest, it's not the role of carrier Wi-Fi in presence is a little bit complex, but one of the key things that operators are moving on from is actually moving on from the coverage and capacity problem that they're solving. Actually, how do I cover more of the country and provide more capacity into all of the corners and crevices of the built environment as well as the rural environment? And how do I do that? So it's not just about carrier Wi-Fi, it's about providing the best possible service that you have using all of your spectrum resources, and carrier Wi-Fi, carrier LTE-U is one tool in your toolbox for providing that. And the other applications beyond coverage and capacity, such as presence, which is the particular topic of my presentation, are key to that. And the carrier Wi-Fi not only carries traffic, but also allows you to provide those presence services, which allow operators at least to provide authenticated credit card transactions, identity confirmation, analytics type applications, for retail verticals, banking, and so on, those kind of things. So there's a lot. The idea of all of these things stem from the fact that you're allowing the carrier much more access to much more spectrum, and that just allows them to do what they need to do with much greater confidence, much greater freedom, much greater quality.
Very comprehensive and in-depth answers. Nick Johnson, thank you.
Well, thank you for having me.